I've been experimenting a bit more with the QRP Labs ProgRock2 programmable crystal. If you've seen my previous video, I've done some experiments trying to use this little device as a replacement for the crystal in a tiny receiver, something like a Rockmite, so you can use it with multiple frequencies without having loads of crystals to switch. And in that video I used some manual switches to demonstrate it, but this could be done by grounding the contacts and using a processor or something like that. Gives me binary 1, so that's bank 1, and then the second column bank 2. Is that right? Yes. Anyway, the main aim is to eventually perhaps make my own little homemade QRP transceiver, and so I've now done some experiments using the ProgRock2 to see if I can use it as the oscillator source for a tiny transmitter. So in this video I'll show you what I did and how I experimented with making some small models to test this out. To try out the ProgRock2 I made 3 new modules: an oscillator, a transmitter circuit and a low-pass filter, and I fitted them to my 3D printed baseboard. So I'm using just these 3 in this video, and the circuit runs from the oscillator through the transmitter and then into the low-pass filter and onto the antenna, or dummy load at the moment. For the transmitter oscillator I used the spare ProgRock2 that I had purchased and fixed it to a breadboard strip board by connecting the ground, voltage input and the 3 clock outputs with stiff wire to give it some rigidity. I also soldered some wires to the bank grounding contacts to use later on. I added 2 SMA connectors for clock 0 and clock 2. I used clock 2 for this simple test and just programmed one frequency, which was 14020 in the 20 meter band. The transmitter is very similar to the output stage of the Rockmite, just 2 transistors amplifying the RF signal, with the output transistor being a 2N2222A in a metal can. The low-pass filter is again made from a kit from QRP Labs. This meant I could quickly assemble it and be confident that I had good quality components. Before using the filter, I tested it with a nano VNA, and I was really impressed by its characteristics, which we'll see in a moment on the oscilloscope. The insertion loss seems to be about 3 dB, and I wonder if some of that comes from the way I've mounted it. Everything about this kind of circuit is better if you can get it directly onto a board with short leads and everything close together. To test the circuit, I connected the output from the filter to a dummy load and connected that also to my oscilloscope and power meter sometimes. So let's take a look at what happens when I apply power to the transmitter circuit. I've set the oscilloscope to its FFT function to give an idea of both the waveform and the frequency domain as well. So let's turn on the transmitter, and there's the waveform at the top, and underneath we can see the output signal and then a very steep slope as the filter does its job really well. The carrier sine wave is clear and just what I need for my transmitter, so I'm very happy with that and with the signal from the ProgRock2. I can't test it yet on the air as I need to set it up to work with a receiver and to be able to key it, but I'm very happy with this test so far, and I'm sure now that I can put everything together to make a simple transceiver. Let's look at the frequency again on the tiny SA spectrum analyzer, and it's clear that any spikes or unwanted signals are at a level well below the CW carrier that I want to use. You'll see that I've fed the transmitter signal into the tiny SA through a series of attenuators to make sure I don't destroy it during its first ever useful session. I estimate the power output at between 1 and 200 milliwatts, so I don't think I'm going to interfere with anyone, and I've deliberately kept this power low for testing purposes. So I hope you found that interesting. I've really enjoyed working on this project so far, and of course the ultimate aim is to make an actual transceiver I can use and make contacts with QRP home built with multiple frequencies, and in the first instance it's quite fun to make it a bit like a crystal controlled transceiver from days of old, but perhaps without having to wire in loads and loads of crystals. So that'll be fun to do. And I'll be back soon with more videos about this project. Obviously the next one I hope will be a complete working transceiver, even if it's still on a temporary board. And then after that I'm hoping to make some more videos about this topic of making home-built equipment, QRP transmitters, receivers, and what's involved, and perhaps to pass on some of what I've learned and encourage other people to do the same. So thanks for watching. I'll be back soon with more videos.